Hello and welcome to my YouTube channel. This video is in continuation to the previous video. In the previous video, we saw how to measure the temperature, but due to time constraint, I ended the video without showing how to average all the temperatures value. Now in this video, we are going to see how to average the temperature sensors value so that we don't get a continuously very randomly varying temperature values. So let's start the video. So the connection will remain same. In this we will be using the Nucleo F44 6RE microcontroller board and LM35. We'll be connecting 3.3 volt to the leftmost pin of the LM35, and then we'll be connecting the middle pin of the LM35 to the A1 channel of STM32 Nucleo F44 6RE microcontroller board, and the rightmost pin of LM35 will be connected to the ground pin. Now let us see how we can write the code to average all the values. So here you can see we in the previous video we used the CubeMX to activate the RCC. We used crystal ceramic resonator for HSC, and for low speed clock also we used the same crystal ceramic resonator. And in the system mode we just configured the debug probe for trace asynchronous software. That's all. And then we modified the analog section in which we used the ADC1, and in the ADC1 we just configured the in1 because in1 is connected to the channel A1 of the STM32 F44 6RE microcontroller board. Then we generated the C code in which we defined 4 variables, and then we defined few other variables which will read the values of voltage, temperature, ADC value and average temperature. So this variable was not used in the previous video. Now we will be using this variable to store the value of average temperature. Now after this we went to the main code. In the main we use the while1 code to write our program to read the temperature sensors value. Now what I'm going to do is I'm just going to comment this code and write a new code to read the temperature sensors value and average it out. Now let's start the coding. So let me declare a new variable float temperature underscore sum, and let me declare it 0 degree. Okay, and then we can write a loop, for loop, and in this for loop we can initialize a variable I which will start from 0 and which will connect all the variables of the ADC till it reaches the value of number of samples. So if you recall, we have declared number of samples 10. So that means we'll be averaging 10 samples of ADC to convert to a temperatures value. You may change the value of our number of samples. The more the number of samples, the more time you have to spend to read the ADC's value. The less number of the samples, the faster the reading will be. So we'll be averaging out depending on the number of samples. and then we will increment it. Now in this we are going to use almost the same code. So we will be using hall underscore adc start. Let me just check, because again seems to be some issues regarding the temperature sum float. Okay, let me just try this again. So it says unused variable, so there shall not be any issue in that. I equal to 0 to I less than number of samples. Okay, let me continue with the code. I believe it will work now. Underscore adc control space adc start. Okay, we have the handle here, and then we'll be using the polling method to collect the values. So adc underscore poll for conversion, we'll pass the handler, and then timeout. We are going to use the same 5 millivolt timeout in this case, and then we'll read the value of adc in the variable adc underscore value. For that we can use hall adc underscore get value. Okay, and pass the handler, and then we can take the voltage or convert the adc values to equivalent voltage. Voltage equal to adc underscore value multiplied by v underscore ref. These are the codes which we have already used in our previous video. Okay, so typecasting the value to adc underscore resolution. Okay, now I just made a mistake here. Instead of 8 it should be multiplication. Okay, done. And then after getting the voltage we can convert it to its equivalent temperature. So temperature is equal to voltage divided by temperature sensitivity. Done. So up to this we had made the code in the previous video. Now let us modify further to average out the temperature value. So temperature underscore sum. Okay, equal to temperature, and we can provide a small delay to perform the iterations. So let me take a 50 milliseconds delay. Okay, done. And now after this we can average out the temperature. So average temperature equal to temperature sum divided by number of samples. Okay, and then we can stop the adc by calling the API adc underscore stop. Okay, and we pass the handler, and we can provide a overall delay to this whole process, and like in the last video we can provide 500 milliseconds delay. So this is all about the code. Let me just build the code. There are still 2 errors. Let me check. Okay, done. So we ended with 0 errors, 0 warnings. So let me summarize what we have modified in this code. So we declared a new variable temperature sum, and then we started a loop. This loop will run for from I equal to 0, that means 0 to number of samples. So depending on the number of samples that we have initialized, it will collect the ADC's values, and based on that we will average out the temperatures value. So we will start the ADC. Okay, so we can start ADC, and then we polled the ADC, then we collected the ADC values, and then converted it to equivalent voltage. Okay, and then the voltage was converted to its equivalent temperature. Convert voltage to temperature, and then for the averaging we performed the sum, all the ADC values collected, and then we perform the averaging. Average the values of ADC, or we can say temperature collected. Okay, and then stop the call, or we can say stop the ADC, and overall delay of 500 millisecond. Delay 500 millisecond. So this is all about the averaging and performing the averaging of 10 samples. Let me just rebuild the program. So 0 error, 0 warning, and we have connected the board. So let me just start the camera. We have connected the board and the temperature sensor. So we can debug the code by pressing the debug button, and then we can go to the live expression on the top right, and here we will see the average temperature value. So there is something missing, so average, wait a second, average temperature. Is there any error? Average temperature is not declared. So we have to declare the average temperature. So let me go to the top and declare instead of temp. Okay, there was a spelling mistake. Okay, done. Now let us debug the code. Go to the live expression and resume the code. Now we can see that the program is collecting 10 samples, and at the end it is giving us the average value. So therefore the average temperature is not fluctuating very rapidly. Now let me go to the temperature sensor and pinch it with my fingers, and we can see the temperature is rising. So right now we have a temperature somewhere around 32 degrees Celsius, 39 and 32 degrees Celsius. Okay, and if I remove my fingers, we can see the temperature will further go back to 27 or 26 degrees Celsius depending on the environment. So it is coming down 30 degrees Celsius, 29, 30 degrees Celsius, somewhere around 29, 30 degrees Celsius right now. So this is how we can average out the temperature so that we don't have to see a very randomly changing temperature sensors value. With this, I would like to end the presentation. If you have not subscribed my channel, then I would request you to please subscribe the channel, and if you have any suggestions or comments, please share your suggestions and comments in the comment section, and press the bell icon so that you can get the notifications as soon as I upload a new video. Thank you and have a nice day.